Okay, we're on the air. Okay, good afternoon or whatever time it is in your place. My name is Bernardus and welcome back, I guess. Today we'll be talking about the Java input output, or as I would like to call it, the pipe system, because everything use the open, read, write, close system calls apparently. So yeah, why am I wearing this? After this, I'm gonna record another one of my assignments, so better than change twice, alright? So, okay, let's get started immediately. As you can see, this is my GitHub issue. You can see what I learned throughout the week, and genuinely, this week has been very stressful. Why? It is not exactly stressful, but I've wasted a bunch of time when I could be doing more important stuffs like learning. And yeah, I mean, rest is important, but I wasted too much time on quote unquote rest. I could have been writing fan fiction. Instead, I scrolled YouTube and waste a bunch of time. So yeah, let's get started. Alright, let me. If you see this, do not ask why, alright? Everyone has a favorite character, alright? This is my school, alright. So, do not ask about the banner, alright? Okay, so the first day of my Java input output, I learned how to do input output in the nearest bare metal way Java can get, the most manual way, and the closest it can get into C type of writing into a file. In C, you have glibc or GNU library, but in Java, we have java.io. So yeah, let's get started first. The first one is the non-object way of C. Remember, in C, we don't have object-oriented programming. GNU Linux is the successor to Unix system, so C works quite the same with Unix. Everything is a file, so open and socket still works. It opens connection and returns a file descriptor. This is my code from the, if I'm not mistaken, procstat, if I'm not mistaken, yes. So this is basically it. When I want to talk about where's open, yes, we have open to open a file descriptor to the file. Sorry, we open a file to that path, and here is the code from my procstat CLI for a thread worker. As you can see, everything is a file. We open a /proc, which is in Linux system is the system information via open, while socket is specifically for socket. TLDR, file descriptor is the lingua franca of Linux or operating system in general. I don't know about Windows or Mac, but in Linux, that's it. So we've briefly talked about the C way. Now let's talk about the object-oriented programming way or the Java way. In Java, it is quite the same. Java runs on a JVM, which is a virtual machine, so it resembles closely to real Linux. Java doesn't change the fundamental, but it adds objects so to make the file descriptor in Java consistent. Instead of just a number, it should be an object. Yes. We have file input stream, which opens the file descriptor, and in C you can pass in ORead or OWrite to make it both read and write, but in Java with file input stream there is also file output stream for file input output, as its name suggests. You need to create a buffer and then read it and pass it to the byte, and then we print the new string. Oh my god. And we print it, yes, something like this, and then we write to the file. Yes, this is the result of fos.write because I'm writing to source main.java, and This is not the optimal way, but I guess this is it. Why do we need news? Okay. In Java, stream is unidirectional data. So every open file input stream or file output stream needs a separate file descriptor for read and write. A bit simple because I'm joking with my friends. I was joking with them. So I was in a call with my friends on Thursday evening, if I'm not mistaken. Thursday evening, yes, Thursday evening. I was joking, so I couldn't really focus on my notes. So I'm sorry, it was a bit simple. But this is it, I guess. You basically put file input stream and file output stream, if I'm not mistaken. Correct me again if I'm wrong. This is public learning again. So it just dumps or takes raw bytes. So you need an array bytes to take the how should I say, to take the file's content, and you need to write it in bytes and convert it to string. That's basically it. Okay, then we have, that's the C way in Java, but we have Java way of input output. I was running out of imagination for titles, so I went mad with the section titles. So Java philosophy, global attempt. Java basically bet on the wrong horse, or rather, the wrong penguin. In the early 90s, when Java was born in 1995, the Unicode Consortium, the one who manages the Unicode or UTF convention, if I'm not mistaken again, alright, believed 65,536 characters would be enough for every language on Earth forever, the same bad IPv4 made. Sun Microsystems, who built Java, also jumped on this UCS2, precursor to UTF-16, because it sounds logical. Turns out, Ken Thompson, one of the greatest of all time, who co-created C and Unix, co-invented UTF-8 in a diner. It won because UTF-8 is the same as ASCII, and old C programs won't break when they met UTF-8. And turns out, the same as IPv4 thought that 32 bits would be enough for every devices on Earth. Yes, probably turns out UTF-16 loses its biggest advantage. Maths, ancient symbols, and most importantly, emojis took over. Because it surpasses the 65,000, yes, it loses their advantage. And Penguin still takes 4 bytes and 4 UTF-8 chars. Changing UTF-16 to UTF-8 would break millions or billions of devices. Talk about suffering from your own success. So as a correction, in collection, advanced types and memory costs, a char is actually 2 bytes in Java because of the UTF-16 problem. This is basically the introduction before we go deeper. And then we have from zero to hero, streams versus readers. What was I thinking? Okay, so after we translate sys open, read, write, and close to Java, we will see the Java way of input-output, specifically files. This is because in Windows or Linux, Internet, and basically everyone follow the UTF-8 conventions. We need a translator. In our earlier example, we showed using bytes and translating it to string manually and vice versa for read, due to Java's UTF-16 nature. Meanwhile, in this example, I open file input and file output stream again. This is for another purposes. File reader here. Now, file reader and file writer is the Java way of doing input output, not the new way of doing input output, but the Java way of doing input output. You get me? So basically, file reader automatically translates the Java UTF-16 to UTF-8, while file writer converts it vice versa. Why did I open file input stream and file output stream? It's because it can be converted into a reader using input stream reader that, or should I say it, wrap the file input stream and tells it what UTF to translate to. But we still need a buffer anyway. Chars.read equals file.read buffer equals me -1. Read into the bucket until the end -1. We print the line. This is the ISR buffer, but this is basically the same. I printed the same file twice, so that's basically it. And you may see I wrote flush here. So what is flush? So reader has a small cache, if I'm not mistaken. So Java doesn't hop that in data in JVM's run and immediately does it. So instead of it being stored in the RAM and waiting for many meaningful actions to be done simultaneously, Java makes it so that the flush makes it so that it will be done immediately, not waiting. A simple input stream or output stream doesn't care about your bytes. It's just I'm sorry to say it, a dump pipe. If you shove UTF-8 to Java's UTF-16 nature, Java will show garbage. Reader, on the other hand, converts them directly to UTF-8 to Java's UTF-16 and vice versa. An input stream reader or output stream reader will convert your input-output stream to a reader, which can be applied to a socket. That's it for reader, and then we entered the robust warehouse. Buffered reader and buffered writer. The goat for reading line. Not the goat, but it is definitely not a goat, alright? It is a wrapper for reader. Every time you call .read in file reader or input stream reader, they go to the disk. But for buffered reader, it grabs a massive chunks once and puts them in RAM. Usually 8192, if I'm not mistaken. The next charge you just take from RAM, not disk, while buffered writer does the same thing, but with writing. Holds everything in one massive chunk before going to the disk to save CPU cycles. Why is this more efficient, you might ask? Because if you call the read in file reader or input stream reader, they go to the disk, which needs the operating system permission, if I'm not mistaken. Again, I forget about direct memory access, but I will revisit it later, so rather than calling the system calls read multiple times, rather the buffered reader or writer takes it in one massive chunk. So the next time you just take it from RAM. And remember page table, since the memory has been mapped as yours, you can access it without the operating system needing to interfere. No need for page fault. Buffered writer does the same, but holds everything in one massive chunk before going to the disk to save CPU cycles. Because it grabs huge chunk of memory, you can see _n and \r, which brings the legendary .readLine method. We created them, and then we print them line by line. Right, we add new line and then we flush to immediately put it on the disk. Boom! That's basically for day 2. Now we are moving to day 3. Neo, Java I/O, Reborn and New. Yes, I woke up late during Saturday. Yesterday actually, I woke up late and I finished it in the afternoon. So I still got assignment after this anyway, so let's finish this as fast as we can. So, Neo, the abbreviation for new I/O. Introduced in Java 1.4, if I'm not mistaken again, I forget, and updated in Java 7, it is a way to do file input-output and takes on a different approach compared to stream or reader. So let's get back to system calls, as every process, which a JVM is, needs to interact with the hardware. In system calls, do you remember about mmap in C? Basically, it is a way to get memory in the heap via system calls. But in Java, it is a bit different. In Java, we have the heap, remember? Now, there are two types of heap. The heap, the actual heap, the JVM heap, or you might call even, and the off heap or native memory. The heap is what we learned. JVM slash garbage collector manages it, while off heap or native memory is managed manually the programmer or OS, with caveats, which will be explained later. And then we have buffer, the gatekeeper. Buffer is a place where you put your data before you write it somewhere else or access it somewhere else. Input output, you write it directly to an array of byte, or copy it from a buffer reader, or read line by line with file reader. But in new input output, you use a byte buffer that comes in two flavors. Heap byte buffer, it lives on the JVM heap, and when you eventually tell the OS to write this buffer to the disk, JVM has to temporarily copy this data into a hidden direct buffer first, because the garbage collector might move your heap array mid-system calls. And then we have direct byte buffer. As its name suggests, it is a direct and directly lives in native slash off heap memory. The JVM basically does this stuff. Gives a raw pointer, there is no copying, the kernel writes directly from your RAM to the disk controller. I need to try. Yes, you might get suspicious about this one, but yeah. Direct, we put the hello world in the buffer using bytes, we flip it. Okay, we might need to search on this one. Okay, okay, rather than being wrong. All right, the flip method on a direct byte buffer or any byte switches the buffer from writing mode to reading mode. Alright, so get back to the node. After we put this one, we flipped it to the reading, so we can print it to the system output. Oh yes, I understand. So this is what it will be outputted. Yes, that's it. However, yes, your suspicion is true. If direct byte buffer lives on the off heap and is unmanaged by garbage collector, and it was created using map, how we call munmap. The reason is garbage collector. So in Java, it is memory safe by default. You have no access to mmap or munmap. But yes, this specific byte buffer actually uses the mmap. So how to clean it is something like this. So when you create a direct byte buffer, Java creates a small shadow object called a cleaner. Both the buffer and cleaner live on the heap, but the reference again lives on the stack. So reference loss. You set your direct byte buffer to null, garbage collector discovery. During the next garbage collection cycles, the garbage collector sees that the buffer object is unreachable. Instead of just deleting the object, the JVM places the associated cleaner into a special reference queue. The reference handler thread, a high priority background thread in the JVM, constantly watching this queue. It pulls the cleaner out and runs its clean method. The clean method finally executes, and the native code that calls munmap are free in the OS. But remember when I said let GC do its thing previously? This time we need to actually interfere in the janitor's work, because garbage collector only triggers when the JVM heap is full. So if you keep creating a direct buffer while the JVM heap is empty, eventually the gatekeeper will call in the final pause of processes. Out of memory error. So you can use a manual cleaner which can trigger undefined behavior or worse segfault, or use the modern way. Arena, 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 yes, arena. We input everything, file channel, we have path here, this is arena of shared, and then we open this one, we open it, and we have the option to read, write, and create. We pass in the memory segment, and then we put it inside the file. Memory unmapped, robustness. Arena is basically the boss of memory management. When the arena goes out of scope, it calls unmap immediately, ensuring memory safety. Basically, resource acquisition is initialization in practice. File channel will be explained after this. Just for your information, I'm using JDK25 and will use the latest official way for new input output. Input output, yes. And then we have path, channel, and segment alongside arena actually, but this is the trio of new input output. So we already saw that arena is the one managing memory lifetime. So now we have path, channel, and segment as the way to do input output efficiently and safely. Think of it like this. Path is a string that holds the path to the file we're dealing with. File channel is it opens the file and is the file descriptor that gives us access to the file. And then we have memory segment. It calls memory map under the hood, putting the file in RAM. So when you write or read, you can directly write to where it is in RAM. So if I'm not mistaken, right? It calls map under the hood, putting the file in RAM. So when you write put, it will automatically be written in RAM before the operating system writes it to the disk. If I'm not mistaken, again, correct me if I'm wrong. And then before we go to the closing, we have little endian and big endian. How do we write a number? So endianness is simply the rule that determines the order in which a sequence of bytes is stored in memory for data that has more than a single byte. The CPU has to decide which one goes first. We have the big endian. This is the human way of doing things. It's 10, not 01. 10 is bigger than 01. From left to right. And then we have little endian. It is basically the reversal of big endian, my mistakes, I'm sorry, and used by machines because of addition and typecasting. Remember column addition in primary school? Yep, that's it. When you add 11 to 12, you don't... Oh my lord, sorry. So when you do addition, right, you add the least significant number first, basically the behind first. The CPU makes sure that the number is stored backward because it is easier to do addition this way. Instead of jumping, you can immediately start adding things. Yeah, that's basically it. And then I print this one. And I just get a revelation after hours of suffering. Yes. Endianness doesn't matter in .txt files, it's just a string. I am writing raw bytes to .txt instead of ASCII. Endianness mostly matters in networking due to the big endian being mandatory. So that's basically it. And as a closing, remember that system out, std out, std in, and stdr are already preserved by the operating system, specifically in Linux or Unix systems, to be 0, 1, and 2, with the order being system std in, std out, and stdr. And Java just wraps them nicely in system.out, system.in, and system.r. That's basically it for everything that I've learned this week. I haven't made a CLI yet. That's because I'm planning to do so in the next week. If I'm not busy, alright? Please. I hope I won't be that busy again. I don't know. I just want to play games, man. So next week, I'll run processes and threads in Java so we can create a multi-process, multi-threaded CLI that'll be useful for me, and then I can learn server and socket programming before finally coding the final project for Java, which is a mini Tomcat, if I'm not mistaken. Yes, mini Tomcat. Yes, mini Tomcat. So yeah, that's basically it for today. I've been recording for the past 25 minutes. The videos have been getting shorter and shorter lately, right? Maybe it's because I didn't copy paste them in the VS Code and explain them one by one, instead only explain them in Obsidian. I don't know if you guys watch this video until the end, but you can tell me, do you want to see a more tough, deeper investigation, or this is enough and sufficient? Up to you, but yeah, I'm gonna end the recording now. I, Bernardus, thank you for watching, and I am signing off. See you next week.